Today we're going to take a look at the factored form of a quadratic relation. So in our first example, we're going to see whether or not this graph, y equals negative 2, x plus 1 times x minus 5, is a parabola. And if it is, in what direction does it open? We're going to approach this problem by using a table of values. So we're going to use x values from negative 1 to 5. If we sub negative 1 into our relationship, we get negative 2 times negative 1 plus 1 times negative 1 minus 5, which equals negative 2 times 0 times negative 6, which equals 0. Next, we'll put in 0, so we get negative 2, 0 plus 1, 0 minus 5, which is negative 2 times 1 times negative 5, which equals 10. Next one, we get negative 2 times 2 times negative 4, which is going to give us 16. And then we have negative 2 times 3 times negative 3, which is going to give us 18. And then you can try the rest, and you get 16, 10, and 0. Remember to find the first differences, or the delta y's. We're going to go across and subtract the number above. So we get 10 minus 0, which is 10. Doing the same thing, we're going to get 6, then 2, then negative 2, then negative 6, and then negative 10. Next, we can find the second differences, which is the subtraction of the first differences. So that's 6 minus 10, which equals negative 4. 2 minus 6, which equals negative 4. And then again, we're going to get negative 4, negative 4, and negative 4. So since the second differences are constant, this relationship is quadratic. What about the direction of opening? So we've talked about this before. Since the second differences are negative, that the parabola opens down. Negative, frowny face. There you go. So this is what we call the factored form of a quadratic, because it's represented with factors. We have the factor negative 2, we have the factor x plus 1, and the factor x plus 5. Continuing on with this example, let's go to example 2. Determine the y-intercept, the zeros, axis, symmetry, and vertex of this quadratic relationship. So we have all the points up here. We're now going to graph them on the grid given here. So we're going to start with negative 1, which we knew is 0. And then 0 we saw was equal to 10. 1 we saw was equal to, let's go back, 16. Next one was equal to 18. 3 was back down to 16. 4 was back down to 10. And then 5 was 0. So there is our parabola. So now we see that the y-intercept is at 0 and 10. The zeros we can see are here and here. So we have the first 0 at -1 and the second 0 at 5. The axis of symmetry is right there. And the axis of symmetry is x equals 2. And then we have the vertex, which is a combination of the axis of symmetry and the optimal value. So the vertex is, and we see that's at 2 and 18. And finally, if we were asked, we would state that the optimal value is 18. Remember, that is the y value of the vertex. So from the graph alone, you should be able to identify our vertex, y-intercept, zeros, axis of symmetry, and optimal value. You should also be able to tell me what the second differences for this relationship are by looking at the graph, which we've shown above would be negative. But what about solving for all these values without a table or a graph? So in example 3, we're going to determine the y-intercept, zeros, axis of symmetry, and vertex of the quadratic relation algebraically. So let's start with the y-intercept. The y-intercept, we know we're going to let x equals 0. So if we let x equal 0, we get y equals -2, 0 plus 1, 0 minus 5, which is equal to -2 times 1 times -5, which is equal to 10. So therefore, we have the point 0 and 10 as our y-intercept. The next one, and a little bit trickier, is to find the zeros. So to find the zeros, the same thing, or similar to finding the x-intercepts, we're going to now let y equal 0. So if we let y equal 0, we get 0 equals -2 x plus 1 times x minus 5. We want to find out what values of x, if I sub it into this equation, will give me a y value of 0. And the best way to think about it is what value of x, if I put it into here or into here, will give me 0. So let's start with the first one, x plus 1. If I make that equal to 0, I can solve for x, and I get x is equal to -1, which a lot of you could have seen from inspection. If I put -1 in for the x value, I'm going to get -2 times 0 times -6, which is 0. Similarly, if I take the other side, x minus 5, and I solve for that factor, I get x equals 5. We call these our zeros. If I put 5 into that equation, I get -2 times 6 times 0, which shows that the y value is equal to 0. So we saw that x is equal to -1. So remember that y equals -2, -1 plus 1 times -1 minus 5. That's -2 times 0 times -6, which equals 0. Same thing over here. If I use that 5, I get -2 times 5 plus 1 times 5 minus 5, which is -2 times 6 times 0, which equals 0. All right. So to find the zeros, we just let each factor equal 0, and those will be to the two zeros. And again, most of you can see just by looking at it that if I put 5 in for x, I'll get a 0 for the one bracket. If I put -1 into the other bracket, I'll get a 0 as well. we got the y-intercept, we got the zeros. The next part is the axis of symmetry. Well, the axis of symmetry can be found by using the zeros. So to find the axis of symmetry, we're going to take the first 0 plus the second 0 divided by 2. So find the midpoint. So in our example, we have -1 plus 5. We'll divide it by 2. And -1 plus 5 is 4 divided by 2, which tells us we have an axis of symmetry of x equals 2. Next, we can find the optimal value. The optimal value is found by subbing the axis of symmetry. We're going to sub x equals 2 into our equation for y. Y equals -2, x plus 1, x minus 5. And we get y equals -2, 2 plus 1, 2 minus 5, which is -2 times 3 times -3. If we multiply that, that's where we get our 18 from. So, we found the zeros, we found the axis symmetry, we found the optimal value, which now gives us the vertex. So the vertex is the axis symmetry 2 plus the optimal value 18, and there is our vertex as shown in the graph above. So we're going to try this a few more times so you become more familiar with how to find a vertex without graphing. Alright, so we're going to sketch the graph of each quadratic relation using the zeros and the vertex. So the first step is we're going to find the zeros. And to find the zeros, we're going to let y equals 0. So we have 0 equals 3, x plus 3, 5 minus x. So we're going to take the factors that contain an x, we're going to set them equal to 0, because if they're equal to 0, when you multiply, you will get 0. So the first one, if we isolate for x, we're going to get -3. And the second one, if we isolate for x, we're going to get -x equals -5. And then we're going to get x2 equals +5. Once we have the zeros, we can find the axis of symmetry. I'm just going to call it the AOS. We're going to use x equals x1 plus x2 divided by 2. So we're going to sub in the zeros, -3 plus 5, and divide it by 2. So it gives us an axis symmetry of 1. Now that we have the axis symmetry, we can get the optimal value. Remember, we sub the axis of symmetry into the equation for y. So we get y equals 3 times 1 plus 3 times 5 minus 1, which equals 3 times 4 times 4. We get 16 times 3, which is 48. And now we have the vertex. The vertex is going to be the axis of symmetry and the optimal value. So we started with the zeros. We got -3 and 5. We found the axis symmetry, which is x equals 1, and we add the two zeros and divide by 2. We find the optimal value, which is 48. Put them together and you have your vertex. And now we can sketch this parabola. So we draw, so we're just doing a sketch, it's just going to be a rough one. So we have -3, 1, 2, 3. There's our first 0, 5, 1, 2, 3, 4, 5. There's our second 0, and our point 1 and 48. So 1 and 48. -3 and 0, 5 and 0, and all we need is 3 points. And we get a good sketch of our parabola. Alright, on to the second one, B. Doing the same thing. We start off with the zeros. We let y equal 0. Now this one looks a little bit different, but we can still solve the problem. We're going to take the negative 5x this time. If that equals 0, then 0 times x minus 4 is going to be 0. But then we also look at the x minus 4. When does that equal 0? So if we divide both sides by -5, we're going to get x1 equal to 0. Add 4 to both sides on this one, and we get x2 equal to 4. So we've got the zeros. Next is axis of symmetry. Remember, is the midpoint of the zeros. So that's 0 plus 4 divided by 2, which gives us an axis symmetry of 2. Now that we've got the axis symmetry, we can find the optimal value. For the optimal value, we sub the axis symmetry into our original equation. So it's -5 times our 2 times 2 minus 4, which is -5 times 2 times -2, which gives us an optimal value of 20. And once we have the optimal value, we have our vertex. So our vertex is our axis symmetry and our optimal value. Next, we can sketch the graph. So we have the point, the first 0 at 0. So that would be 0, 0 for an x-intercept. 1, 2, 3, 4. Our second 0 is 4, so our second x-intercept is 4 and 0. And then 2 and 20 we'll say is here. And once again we have a parabola that opens downwards. Alright, so let's do one more. So the last one is y equals x minus 4 squared, which is still a parabola. It still has two factors here with x's in them. It's just a squared factor. So I'm going to skip some of the writing. We're going to say let y equal 0. So 0 equals x minus 4, x minus 4. And this one's an interesting one, because if we look at both of these factors, we see that our first 0 is 4, and our second 0 is 4. Well, let's see what happens. That means our axis of symmetry, which is x equals 4 plus 4, the first 0 plus the second, divided by 2. It's going to be 8 divided by 2 is going to be 4. Okay. Let's look at the optimal value. The optimal value, we sub in to our equation. It's going to be 4 minus 4 squared, 0 squared, which is 0. So in this case, we have an interesting point. We have the point 4 and 0, which is an x-intercept, which is a 0, but which is also our vertex. So we only have one point this time. So if we end up with something like this, we can also look for what's called the y-intercept. Because in this case, our vertex is a 0, we need the y-intercept. So we're going to let x equals 0, and we're going to get y equals 0 minus 4 squared, which gives us a y-intercept of 16. So let's look at what this graph would look like. Alright, so let's plot the points we have. We have the vertex, which is 4 and 0. We have a y-intercept, we'll say is up here. That's 0 and 16. So we have half of the parabola here, And we know there's got to be another half that's symmetrical. So if 0, the y-intercept, over to here, this is the vertex, they're 4 units away. So that means there has to be another point over here at 8, which is also at 16. Because remember, we have this axis of symmetry, which makes a mirror image. So 8 is 4 units away from the vertex to the right, where 0, it's got to have a matching point because of the parabola. So the other point that matches to it is 8 and 16. And all I did was count. 4 units this way, 4 units that way. Right. So let's look at what we've done. So the factored form of a quadratic relation, we know has to look something like this. Y equals a, x minus x1, x minus x2. Not exactly, but in many cases it looks like this. Each factor can be used to determine the zeros. So when I look at each of these factors, remember I take each of them and I solve for when they equal to 0. Remember, the axis of symmetry passes through the midpoint of the zeros. And then the optimal value is the y value determined using the axis of symmetry. So with these 3 steps, finding the zeros, finding the axis of symmetry, and the optimal value, you can find the vertex of a quadratic.